When discussing about the inventory, other than economic order quantity and probabilistic model, we have another type of inventory. We will discuss a lot about this other model of inventory in this video.
Let's discuss further about the other inventory model. In the previous video, we already learned and discussed about the economic order quantity model when we assume that demand and lead time is deterministic, and then we extend further when there is a quantity discount, and then again we extend further into the probabilistic inventory model that we assume the demand and lead time is no longer deterministic. So what is the other inventory model in the inventory management? Let's see about that. The first model that we would like to discuss is the production order quantity model. Consider the situation like illustrated in this graph, that there is a time when a part of inventory cycle there is during that time there is a production and also usage is taking place. So production and consumption is taking place at the time. So it's illustrated in this red line. Yeah, and then when reaching the maximum inventory at time t, and then the consumption without the production, of course, so consumption only is take place. And the similar pattern is continuing to the future. So the pattern in here in production order quantity is there is a time when the production and consumption take place, and there is a time when there is a consumption only take place. So how to calculate the maximum inventory or the optimum order quantity in this situation? So in this situation, since the production order quantity is used when inventory build up over production of time after an order is placed, so we introduce in this case the several variable that we will use. Q, this is also same with the previous one. Q is number of order, and H is a holding cost. So this is Q, this is H, holding cost. D, this is D, capital D is annual demand, and then small d is a daily demand. And P, we introduced, this is the new variable. P is daily production rate. Previously, we don't have this variable. So how much the optimum of order? So determined by this formula. Square root of 2 multiplied by D multiplied by S divided by H in this case, and multiplied by 1 minus D per P in this case. Previously, we don't have this multiplication of 1 minus D per P. So this is the modification of the economic order quantity model when there is a time of produce and sold simultaneously. The second model is, we call it the fixed period inventory. Consider the situation when we have the target inventory this much. For example, this is a maximum inventory that we can have in our warehouse. And then over the time, we have to reach this target of quantity. When we order, we should reach this target of quantity. So when we order, in this case, when we order, it is kind of like different with the previous AOQ model. In AOQ model, we order based on the quantity. When we reach certain amount quantity, 400, for example, when we reach a number of 400, for example, we should order. But in this case, yeah, the way not works like that. So we order based on the time, for example, once a month, once a week, for example. So in this case, the period of ordering is the same. So this is the P is the period. Yeah, the period is the same, but the quantity that we should order is different over the time. So this is the first quantity that we order at this time, and then this is the second one at this time, and we can continue on like this one. Since the pattern of demand is quite fluctuate, so each time we order, we have different quantity of order. This is, we call it the fixed period inventory model. In fixed period inventory model, order placed at the end of the fixed period. So we should determine, or the management should determine, in which period they should order. Inventory is counted only at the end of the period. This is the rule that we have to make our inventory record is as accurate as possible in order to be able to do this. The third one, order bring inventory up to the target level. Again, the management have to determine how much the target level is. Number 4, only relevant costs are ordering costs, and holding costs in this case. Number 5, lead time are known and constant, and items are independent from each other. Consider the simple example of the fixed period inventory model. We have 3 jackets that is back order from the previous ones, and we don't have currently the jacket in stock. And then we have the target value of 50. So how much the order amount at this time? So we can simply calculate based on this one. So the target minus the inventory that we have now minus the earlier order that we not yet received, and then plus the back orders. So it is equal to 50 minus, since we don't have on-hand inventory, so this is 0. Schedule order is also 0, and then plus the 3 jacket in here, 3, that is back order. So in total, we should order 53 jacket. It's quite simple calculation in fixed period inventory model. Single period model. This is the model when there is one order is placed for a product and the unit have a little or no value at the end of the sales period. Consider there is an inventory for a newspaper, for example. The newspaper, when we sell the newspaper, it is only used for that day. When we sell beyond the day of publishment of the newspaper, the salvage value of the newspaper itself is very, very small, or maybe no value at the end of the sales period. So this single period inventory model is also common with the news vendor model, commonly called with the news vendor model. So here we have several costs to be considered. The first is cost of shortage, which is the sales minus the sales price. This is sales price per unit minus cost per unit. And then there is a cost of overage, which is cost per unit minus the salvage value. So the service level we can calculate in this case is cost of shortage divided by cost of shortage plus the cost of overage. Take a look at this simple example. We have the average demand 120 and standard deviation is 15 paper, and the cost of shortage, since the sales price is 1.25, so minus the cost is 0.70, so we have the cost of shortage is 0.55. So the cost of overage is the cost, so 0.7t minus the salvage value. Yeah. In this case, they have salvage value 0.3. So in total, the cost of overage is 0.4. Here, we can calculate the service level based on this cost of shortage and cost of overage, and resulted the number of 0.578. Based on the normal distribution function, when we have the service level of 57.8, we can determine how much the stock level that we should keep in our inventory, considering that we have the average demand is 120 and deviation is 50. Thank you so much for joining me discussing about the others inventory model. See you again in another topic.
Thank you so much for joining me in Learning Operation Management. See you again in the next video.